Ever heard of pair programming?
Sounds kind of fun, right?
Hmm.
Like coding buddies.
Yeah, exactly. It's where you've got two people working on the same computer on the same like programming task.
Hmm.
One person is, the driver, the one at the keyboard actually writing the code,
Right.
and the other person's the navigator.
Ah, so they're like the strategist.
Yeah, kind of. They're thinking ahead, checking the code, suggesting stuff, asking questions. The
Interesting.
trick is they switch roles regularly, so you're not stuck in one role the whole time.
Makes sense. Keep things fresh. Now, where's this deep dive taking us?
We're looking at pair programming, but not for the usual suspects, not for like hardcore computer science or software engineering majors. We're focusing on the MIS folks
MIS Management Information Systems. Why them?
because they usually only take like one programming course,
Oh,
right?
oh, right.
Unlike those CS and SE students who are coding day in and day out.
Right, right.
So getting those advanced skills in just one course, that's a big ask.
True, true. So, thinking about how IS pros actually work, the IS 2010 curriculum guidelines, they really stress teamwork and collaboration for IS professionals.
And for good reason. That's how it is in the real world.
Exactly.
Okay, so where are we headed with all this? Our mission today is to explore if pair programming can really boost learning for these MIS students, especially given their limited programming experience.
Sounds intriguing. What's the source material for this dive?
We're digging into a study from East Carolina University.
ECU, all right.
They did 2 experiments, then analyzed, the programs the students wrote, how they worked together, and what the students themselves thought about the whole thing through surveys.
So what were they hoping to find? What were they looking for in these experiments?
Okay, so the study focused on 4 key areas. First up, technical productivity, which is basically how much coding they got done.
Right, right. Makes sense.
Second, program and design quality, like how well structured their code was, how effective it was. Then there's academic performance, their actual grades on the assignments. And finally, their own perceived satisfaction, meaning how they felt about the pair programming experience.
So pretty comprehensive. They wanted to see how it affected them on all levels.
Exactly. And for context, back in 2005, people like Borshinsky and his colleagues were already highlighting that this single programming course was a real hurdle for MIS students.
Interesting.
And the lead researcher in this study had seen this firsthand too.
Really?
Yeah. It wasn't like pair programming was a brand new concept either. There's research on CS and SE students showing potential benefits like, more code getting written, better quality code, improved grades, even higher satisfaction, and more students sticking with their majors.
I can see how that would be a good thing. Less frustration, maybe. But were there downsides?
Well, there's always the potential for like personality clashes.
Oh, yeah, that's inevitable.
And it can seem slower at first. You're investing more time up front.
Right. Investing time to hopefully save time later by avoiding those pesky errors.
Exactly. So the big question this research tackled was, what are the specific benefits of pair programming for the MIS curriculum, given they often only have that one programming course?
Makes sense. So how did they go about answering that question? What did these experiments look like?
They did these lab experiments within an introductory software design course using visualbasic.net.
VBNet, okay.
They didn't just look at the code, though. They used surveys, too, even borrowing questions from the NCWIT, the National Center for Women in Information Technology.
Interesting.
Let's talk about the students. In fall 2014, they had 21, and in spring 2015, 9.
Okay, so a smaller group in the spring.
Yeah. Now get this. In the spring, none of the students had any prior programming experience, but in the fall, about a quarter had some.
Oh, that's a significant difference.
Right. Gender-wise, both groups were pretty similar, about 1/3 female. And the fall students said they spent a bit more time studying overall.
Interesting. So different levels of experience and study habits could definitely play a role. Tell me about the setup. How did they do the pairing?
They went with random pairing after, get this, doing a pilot study to try out different pairing methods.
Oh, wow. Really thorough.
Yeah. They used workstations with those big wall-mounted monitors.
I bet that helped with observing.
Absolutely. They video recorded everything, anonymized, of course, and they gave the students this document called Fun with Pair Programming.
Cute. Like a guide.
Yeah, tips on how to work together effectively.
Makes sense. So what was the programming task they gave them?
It was a problem straight from their textbook about calculating the annual cost of commuting using a train or a bus.
Practical. I like it.
Right. So not just theoretical stuff, it required them to handle both the basics, like data conversion, calculations, input validation, and also more advanced stuff.
Like what?
Sub-procedures, combo boxes, nested if statements, even a splash screen.
Wow, that's a decent challenge, especially in one course.
And get this, they didn't give them a design diagram for the application. They had to figure out the user interface themselves, too.
Interesting. So they really had to think about how the user would interact with the program. That's a whole other layer of complexity.
Yeah.
Did they have enough time for all that?
That's where things get interesting. In the fall, they had 3 20-minute sessions, and they had to switch driver-navigator roles in each session. But in the spring, they gave them a full 120 minutes.
Why the change?
Because a lot of students in the fall experiment didn't finish.
So they needed more time.
Yeah.
Makes sense. Now, how did they grade these programs?
The instructor was the expert evaluator, and they used a rubric. They looked at the design of the interface, the code itself, if the program actually worked, and if it gave the right output.
Okay, so pretty comprehensive grading.
Right. So, drum roll, please. The overall trend was the pairs scored higher than the individuals.
No surprise there. But how much higher? Any details?
In the fall, the top pairs got the calculations right, but maybe had small issues with validation or sub-procedures. But lots of programs, both pair and individual, were either incomplete or didn't have those advanced concepts we talked about.
I couldn't quite get there.
Yeah. And surprisingly, some individuals even struggled with basic data conversion.
Really?
Yeah. The average scores show it clearly. Pairs got around 57 out of 100, individuals got about 44, and only the pair scores went above 60.
So working together helped them reach a level they couldn't individually.
Exactly. What's cool is that's with just one programming course under their belts. So think about how we can help these students.
Definitely. Now, in the spring, they had way more time. Did that change anything?
Well, not everyone suddenly aced it. Only one pair got a perfect program.
Oh, wow, just one.
Yeah, some individuals still had super basic programs and struggled with those basic concepts, but again, pairs did better on average, 73 versus 53 for individuals. And again, only pair scores were above 60.
So even with more time, those advanced concepts were tough for individuals.
Absolutely. The pairs were better at least trying and partially implementing those harder features, while the solo folks, they mostly skipped them entirely.
Interesting. Did they do any statistical analysis on these scores?
They did an ANOVA test. The overall difference wasn't statistically significant, they think, because of how the rubric was set up. But when they looked at specific things like correct data conversion, the pairs did score statistically significantly higher.
So the broad score difference might be shaky statistically, but there's clear evidence that collaboration helped them nail that fundamental programming skill. Now, did they just look at the scores, or did they actually watch the students' work?
Oh, they observed them, and it gives a really interesting perspective. They noticed some individual students were easily distracted, not focused. Some got stuck on a problem and couldn't move past it. One student even just stopped working and
Overwhelmed.
Right. Now with the pairs, it wasn't all smooth sailing at first. Some had trouble truly collaborating,
Oh, how so?
like both trying to control the keyboard at the same time,
Oh.
or one person taking over without much input from the other. There was even one pair in the fall who, never clicked. One person took over completely, the other felt left out.
So not every pairing is magical.
Right. It highlights the need to learn how to collaborate effectively. But thankfully, most pairs weren't like that. As time went on, they found their groove. They talked more, worked through problems together. There was even a pair in the fall who were laughing and having fun while coding.
Now that's what we like to hear. Learning should be enjoyable.
Exactly. And in the spring, all the pairs seemed to work well. Even one pair who found it tough, they kept communicating, even joking about being a bad match, but in a lighthearted way.
Good to hear they could keep it light, even under pressure.
Right. The individuals, though, they struggled consistently in the spring.
So overall, it seems pair programming led to more engagement, more active collaboration, something that was missing when they worked alone.
Right. The researchers specifically mentioned the difference in atmosphere. Engaged and collaborative during pair programming, stressed and isolated during individual programming.
Makes you think.
Yeah.
So what did the students themselves think? What did the surveys tell us?
Well, most thought their partner's abilities were similar to their own, and they felt compatible, even though the pairings were random.
Interesting. Considering those not-so-successful pairings we discussed.
I know, right? And most thought the programs they created together were the same or better quality than what they would have done alone.
And how did they feel about the pair programming experience in general? Did they like it?
Mostly, yes. They said having a partner made the assignments easier, boosted their confidence in their code, helped them discuss problems, and even helped them learn to read other people's code.
Those are some significant benefits.
Right. Most felt comfortable in both roles, driver and navigator, and were happy with their partners. A lot of them agreed that pair programming leads to more success than solo programming and would recommend it. The spring 2015 group was especially keen. They wanted it in all their programming classes.
Wow. So they were really sold on it.
They were, but there's a little twist. When they actually implemented pair programming in the regular course for grades, the survey results were less overwhelmingly positive.
Oh, why do you think that was?
They think it's because the grades added pressure. In the experiments, it didn't affect their grades, so maybe they were more relaxed.
That makes sense. But did the instructors still like the method?
Yeah, they still believed in it and kept using it in later semesters.
That says something. Were there any interesting comments from the students themselves?
Oh, yeah. Some called it a good exercise and liked working with a partner. Some wished they had more time with it or had taken the collaboration part more seriously. One even suggested working on a more difficult program using pair programming.
That's interesting. Wanting a bigger challenge, that shows real engagement.
Right. So looking at everything, the program results, the observations, the surveys, what does the study tell us about teaching programming to MIS students?
Well, the researchers say it's a big deal that MIS students, who only do a little programming, got similar benefits from pair programming as those CS and SE students who do a ton of it.
Right. It's not just for the programming whizzes.
Exactly.
Hmm.
It suggests we can improve the MIS curriculum, especially when you think about what MIS grads actually do.
Right. They're often the bridge between the tech teams and the business folks.
Exactly. So understanding software development, even if they're not coding all day, it's super valuable for them.
And maybe pair programming can help them get over that initial fear of tailing.
Yeah, make it less intimidating, more collaborative.
Could even help keep more students in the MIS major.
I could see that.
Yeah.
And the lead researcher talked about students who struggled with programming but ended up having great MIS careers.
That's encouraging. Real-world proof.
It is. Of course, every study has its limitations.
Yeah.
What were some of the ones mentioned here?
They talked about the time limits in the experiments, even though they did extend the time in the second one. It's still unclear what the ideal length for a pair programming session would be.
Right. And the survey data.
Yeah, they acknowledged potential bias there. People don't always report their experiences perfectly accurately.
Of course.
And the sample size was pretty small, so it's hard to say for sure if these findings apply to all MIS students.
Makes sense. But they did keep using pair programming in their classes afterward, right?
They did, and they plan to keep doing it. They also suggest more research, like looking at how pair programming affects MIS student retention and what other benefits it might have for them.
So for our listeners, what's the big takeaway from this deep dive into pair programming for MIS students?
The main message is that even for students who aren't focused on becoming expert programmers, pair programming has a lot to offer. They wrote better programs, were more productive, especially with those harder concepts, and they enjoyed the experience. And that lines up with what we've seen in studies with those hardcore CS students.
Right, it's not just for the tech-focused folks. The aha moment is realizing that even in fields where coding isn't the main thing, using collaborative methods like pair programming can really help students understand software development and feel more confident.
It makes you think. We talk about teamwork all the time in all kinds of jobs. So could we take those principles of pair programming, that shared understanding, communication, problem solving, and apply them to other tasks beyond coding?
That's an intriguing question. Could lead to better outcomes, more efficiency, a greater sense of shared success. Definitely something to ponder.
Lots to think about. Thanks for joining us for this deep dive.